A little over a week ago, I had almost zero deep security engineering knowledge. 6 days later, I deployed OpenClaw, one of the fastest growing open source agent frameworks inside the world right now. AI agent that runs autonomously and is able to have multi agents within the system. To a secured cloud server, 7 overlapping security layers, a full threat model, and stress tested in production. I'm not a security engineer. I'm not a network engineer. I never studied any of that formally, but I used AI to learn it, build it, verify it, and then audit every decision along the way. Now it's one of the strongest items in my portfolio. In this video, I'm going to walk you through the high level process of how I did it, the methodology, the thinking, the mistakes, so you can apply the same approach to whatever you build next. And this is not going to be a step-by-step tutorial. This is a playbook to learn to build something complex with AI when you're starting from near zero and when you're trying to build something complex. And here is going to be the methodology that I use. These are the exact skills that I believe analysts and data professionals are going to need to know to stay relevant as AI changes everything and how we work. So I'm going to walk you through how I broke the build into phases, why I spent 2 days researching before I touched a single config file, the specific techniques that I use to get better answers from AI, including one adversarial prompting trick that uncovered vulnerabilities that I would have never found out on my own. I also used three different AI models for the same project and what each one caught that the others missed, and the one non-negotiable skill that I didn't fully understand until I spent 6 days building. It's not a tool, it's not a framework, it's what most people are completely overlooking. My name is Jeff. I've worked in healthcare analytics and operations for over 15 years. I currently work as a business analyst consultant at a Fortune 5 healthcare company. I've reviewed resumes, sat on hiring panels, and conducted technical interviews. And what I'm about to share comes from real experience building with AI, not theory. Not going to be a course summary. This is just 6 days of me with my head down, working 10 plus hours a day, making it work. So here is exactly what happened. So I discovered OpenClaw from a friend. This is an open source autonomous AI agent framework. And when it launched, it went from 0 to 100,000 GitHub stars in under a week. One of the fastest growing open source projects in history. And now I didn't just read about this and stay on the sidelines. I wanted to run it and get my hands dirty and try to figure out what makes it tick. But running an autonomous AI agent framework isn't in like installing an app. This thing connects to the internet, it has exposures, it executes code, it deploys. If you deploy this carelessly, you're basically leaving your front door open to hackers and potential attacks. So before I wrote a single line of configuration, I needed to understand the risk. So for some quick context, I'm a person who deeply cares about cybersecurity risk, and I practice good cyber security and hygiene on my main machine. I've hardened it, I've reduced the attack surfaces because I've seen too many people get hacked. And so my main machine that has critical data, that stays isolated. All the development work that I do happens on a separate machine on my laptop that never connects to my critical machine, and it never connects directly. So this is not some genius strategy. This is just minimizing my exposure so I don't accidentally do something that could affect my main machine. But what this meant is I had the mindset of already thinking of attack vectors. I already had some of the language. I just didn't have the deep technical knowledge yet. So what I did for day one is I only deeply cared about the major risks. While everybody was touting how crazy this could be and all the work that it's doing and how it's a digital employee, I wanted to see what were the major vulnerabilities, what risks do I open myself up to, what else do I have to be concerned about. So what I did was I compiled full scripts of people getting interviewed, articles, resources that did technical deep dives into all of the security risks, of running autonomous agents, and specifically for OpenClaw. I also had AI, multiple agents, do deep research on these topics, pulling everything that they could so that I had enough context to know where the biggest threats were. So day one for me was building the map, not building the system. Day two is where it gets a little more intense. I'm working with AI, I'm watching videos on risk, I'm watching things like IBM discussions with cybersecurity experts, and I'm asking AI about specific vulnerabilities. What are the trade offs? What are the attack surfaces? What's the severity? What's the probability of this happening? And here's where my background helped in a way that I didn't expect. So I have friends who understand cybersecurity. So I've had surface level conversations with them over the years, but that wasn't enough to build a security system. But it was enough to know how to ask the right questions, and the way that I worded my prompts made it easier to pull the information that we needed from the models that I was using. The way that I worded it, the things I knew to ask about, those came from those conversations with my friends previously. So what I did was I just pushed it a little further. I would ask AI, if I were a hacker, or if you were a hacker, how would you compromise my machine and my security setup? This was the adversarial thinking that opened up the vulnerabilities that I wouldn't have found otherwise. And I wasn't just learning from AI directly, I was also learning outside of it. I was watching these expert discussions, I was reading documentation. I would come back and I would ask better questions. AI filled the gaps of my knowledge, but I was also building my core understanding in parallel so I could verify what it was telling me. And then came the threat model and then the research. And I worked with AI to create detailed implementation plan. And then we laid out the strategy to address every critical cybersecurity vulnerability. And then we kept iterating on that plan. Back and forth, refining. I'd ask questions, I'd propose new questions, I'd think of new scenarios and likelihoods, and then AI would educate me, it would assess the risk, and then come up with a plan. And then we just kept doing that until the plan made more sense and it covered all my concerns. Here's the part that most people skip. They just skip to building. I spent 2 days understanding the landscape and then planning the approach before I touched a single config file. Now, in days 3 and 4, I built it step by step with Claude Opus 4.6. I did this because I started to hear how crazy Opus 4.6 was at reasoning and building, and how much of a level it took above the current models, and it just released. And the results are pretty crazy. So when I say step by step, what I mean was line by line guided implementation. And this is how we eventually got to 7 security layers, give or take, and network isolation, authentication, monitoring, rate limiting, the full security architecture. And this is where it got real, because as we started to do the line by line implementation, this showed me what was missed in the initial planning. These are the details that you can't anticipate until you're actually building and things start to error out. And then you have to troubleshoot. And through that troubleshooting, and seeing AI. So what I did was I looked at Claude, how it was thinking and how it was troubleshooting, and then also how it guided me to figure out where the problem was. I got to learn from the actual doing. And I would ask questions and learn as we went on so that we could create a better system. Then I would ask, how do we verify this is actually secure? And then why? So what we did was, in that process of troubleshooting, it made the model better. It made the security threat model better. And this is one of those things that when you learn with AI is going to be confident, but it's also going to be wrong more than once, especially with a complex build like this. So if I hadn't been verifying everything independently, cross-referencing documentation, testing each layer, breaking things on purpose, smoke testing, regression testing, to see what held, I would have just deployed this system with real security holes, which was what people were finding, the security experts, where it would be easy for any hacker to just get into all of these OpenClaw projects that were launched and then steal people's API keys. So this is what I was able to build and learn inside the process of doing. Now, day 5 and day 6, this is where This is where we started doing more testing, stress testing, load testing, trying to break my own system, and then fixing what broke, and then optimizing what was slow, and then deploying, running it, and then making modifications on my for my own use cases and what I actually needed. And then by the end of this, I had a production ready deployment of one of the hottest frameworks in AI right now, secured, documented, and running. And now I can outline and speak to the level of depth that I went to secure it, every threat that I considered, every layer that I implemented, all the decisions that we made, and how I deployed it, optimized it, and the modifications that I made for my own use cases, and how we went above and beyond just regular deployment to make it secure, and then all the trade offs and risks that we accepted because of that. So, that is not just a tutorial that I followed. That is a system that I built ad hoc for my own purpose. And this is one of the things that you need to start building on your own too, is learning how to use AI for your own targeted learning. And I honestly think this is one of the major places that AI is going to be taking us is catered learning. I'll probably never get the opportunity to deploy OpenClaw like this at my day job, but that's not the point. The point is I used AI to learn security engineering, network engineering from near zero in 6 days. And now I have the proof that I can do it. I have the proof that I can speak to it in depth at any interview. And I also got the practice so I can do it without referencing AI for the most part. Now, let's give you the specific techniques that made this build possible, because the story sounds impressive, but it's going to be the methodology that you can actually copy. What did I actually do that will be helpful for you? So the first thing was create a full context document. So this is the single most important piece of advice that I can give you. Here is the problem that nobody tells you about. AI models have a limited context window. Yes, those windows may seem huge. They might be 200,000 tokens, 1 million tokens. But what people don't tell you is that the depth of their recall is what matters. How accurate are they? How good is the model at finding the needle in the haystack and then remembering a decision that you made 50 messages ago within the context that you need it right now? And that is going to degrade as the conversation gets longer. So when I was building OpenClaw and things started to get complex, the model started forgetting. Decisions that I made earlier and the configurations that we already set, it just didn't fully remember that. And then, or why we chose a certain reason over another. So what I did was I built a living context document. It captures everything, what I've done, what I want to do, every change that we made and why, where we are in the build, and the full specification for implementation. So when a model forgets, and it's going to forget, you just need to paste back the relevant section, or you just paste back the full documentation if you're okay with the token cost. And then what I did from there, it would just be able to catch back up of where we were. And then even if it was behind by a little bit, the troubleshooting that I would go through, especially with Opus, it would just be able to catch me back up and then figure out where we were and then how to keep moving forward. This is one of those things that's going to save you a lot of time, because you could spend 20 minutes trying to re-explain the project and then also be confused on where you are inside the build. This single practice is what helped me build OpenClaw with increasing complexity, and it allowed me to work across agents, across different platforms without losing a single context thread. At least not major context thread, just being able to catch up back pretty quickly. And without it, the complex build, I've tried to build without Opus with just building a very, very complex project, and it just falls apart. So when you have this, you can keep pushing the ceiling higher and higher of what you build and how complex it is. Now, the second advice I would give is use the best models and pay for them. The models themselves are getting significantly better at reasoning, troubleshooting, and working through logic, and also showing their work when you click into the details. And that will teach you a lot of what they're doing. And then you can start learning the thought process and the sequence of steps that they're doing to troubleshoot issues. And this is now happening without perfect prompt engineering. I had to go through a certification, AWS AI practitioner, learn prompt engineering, practice a lot. But now with simple prompts and just more targeted prompts and better questions, you don't have to be a prompting wizard and know best practices and have the context and instructions, the role. It's AI models are getting better at just accepting the questions that you have. You just need to use better models. Yes, they're more expensive, but in terms of productivity and the value gain, I personally believe the trade off, I would take that trade off every day of the week. But again, it's going to depend on what you're using this for and your own use cases if it's valuable enough for you to pay for it. Now, when I built the implementation plan in the phase with Claude Opus 4.6, specifically, I needed that reasoning, that depth for the security architecture decisions. A cheaper model would have gotten me a cheaper result. And with security, cheap results are dangerous results. So I chose to go with the better model. Now, the third advice I would give is you need to red team your implementation plan, get second and third opinions. If you don't know what a red team is, they use this in the military. They have a red, or and in business too. There's the blue team that's all about implementation and execution. There's the red team that's supposed to come in and poke holes into the plan. So what I did to red team and try to figure out what are the vulnerabilities in my own plan is I pay for ChatGPT, Gemini, and Claude. And it's not because I'm loyal to one of them. It's because I want to know the limitations of each. And I have unique use cases for each of how I use them. Now, I want to see how they grow, how the companies are changing, and where they're still weak. But there's also a different practical reason that matters for building. Each of the models catches the blind spots that the others miss. So that's exactly what I did with this build as well. I took my implementation plan, then I asked each model to audit it for gaps, weaknesses, blind spots. So Claude, and then I would open a different context and different chat even in Claude. So Claude caught things that GPT missed. Gemini flagged risks that none of the other ones saw. And GPT found other things to address proactively that the other two didn't. And then if you're building anything that matters, security, data validation, production systems, one model's opinion is not going to be enough. You need to red team your own plan and have those third and second opinions so that you can get better depth of what you're missing. And then 4 is vary your research methods. So you don't rely on one approach or just one source. So what I also did is I had each model do their own deep research. I asked them to compile all known security risks for OpenClaw specifically at the level of detail you'd expect in enterprise-grade threat analysis. So the words that you use will also dictate the output that you're going to get. So when I'm using higher level detail or details that I would need for implementation plans, I would use things like enterprise grade, institutional report, ways to pull out more information out of the model in a way that's detail oriented to be able to build with. And this, so it's not going to be what you normally get back, not surface level summaries. It's going to be deep, specific, categorized by severity and probability. And with ChatGPT specifically, I use both deep research and agent mode for the research because in my experience, I found they return different findings. They have different sources, they have different angles. So then I wanted to vary and get as much research as I could so that I wasn't building on one of the model's blind spots. So the more perspectives that you gather before you build, the fewer surprises that you're going to actually hit during the build. So this brings me to the bigger lesson. And the reason this build worked wasn't because AI is magic. It worked because of how I used it. I didn't just ask AI to write the configs, paste them in, and just walk me through how to build it and implement it. That's how you're going to deploy something that's broken. I had AI teach me. I had it explain the concepts, walk me through the reasoning, audit the teaching. And then I also audited all of the things that it was teaching me just in case it was teaching me something wrong. Because I've been there where I learned from AI and the best practices it was teaching me was not the best practices. So you also have to audit the reasoning and what you're learning from it. At a fundamental level, I would ask questions. I would present new scenarios. I'd say, what would happen if this occurred? Then I would have AI think about it and wait a little bit more and then explain it to me. And then I would also have another AI audit the suggestions and the advice. And then I built, because building is what is going to teach you more than all of this planning and implementation. So this is going to lock in that learning from actually doing something, because you don't really understand something till you've implemented it, troubleshooted through what the issues that occur when you see it break. And that's the cycle. You learn, you audit, you build, you repeat, and then you keep iterating, and then you keep learning as you go. I think that's one of the fastest ways to learn now, because AI is changing everything. And the tools and the software is just getting crazier. There's a non-negotiable skill that isn't AI specifically, because like I said, the tools are going to change every month. The non-negotiable skill is improving how you learn. I think this is more important now, is improving how you learn, how fast you learn, how deeply you retain that learning, and specifically learning how to learn with AI. And not just having AI do the work for you, and not just using it like an overglorified Google search, but having it teach you and teach you deeply. And having you audit that teaching to make sure you're not learning the wrong things, and then learning outside of that so you can ask better questions so you can come back, and then building something real with what you locked in and the learning that you have. And that's exactly what I did with OpenClaw. I didn't just ask AI to hand me the answer. I had it teach me, verify what it taught me against real documentation, experts, and then built the system line by line so the knowledge stuck. And then when AI was wrong, which it was wrong multiple times, I caught it because I had done the work to understand it. Or if I didn't catch it because there's gaps in my knowledge because I'm new, AI was able to troubleshoot through those steps to figure out what exactly was wrong. And then we updated the documentation to reflect that. And then through all of the troubleshooting, I was able to get the reasoning and how AI was able to figure it out. I'm not telling you to go tomorrow and deploy OpenClaw unless you want to. That was my sprint, but your build and what you want to build is going to be different. But what my methodology and how I did it, you can use that to improve for your own use cases. There is a research organization called Meter, METR, that measures how long a task AI agents can complete autonomously. The trend has been crazy. It's been doubling every 4 to 7 months, and it's not slowing down. It's accelerating. And here is what nobody is telling you out loud. The gap between people who are building with AI right now and the people who are planning to learn AI eventually is growing at an exponential rate. Every month that you wait, the people who started learning last month are compounding on the growth that they're having. They're faster, they're building more complex things, they're learning what works and what breaks. I've been talking to friends about this. I've been building autonomous multi-agent AI systems, or at least experimenting them at a service level and then eventually learning how to build them. I've done Claude code training with deep learning AI. I've built simple applications through Claude, ChatGPT before any of this. And in 2025, I was top 1% of users of ChatGPT in terms of messages sent. And what I'm telling you is from someone who's on the ground learning and building every single day. People do not understand how fast things are moving right now. The landscape shifts week to week, day by day, and the opportunity to jump in, learn fast, and pass everyone who's waiting on the sidelines has never been greater. And I honestly believe that. But this window is not going to stay open forever. It's going to be one of the easiest times to be able to get in from scratch to get into data analytics. And AI is not going to replace you, but people using AI will. If you haven't started building, now is the time, not next month, not the next course, now. And if you want real healthcare analytics experience and advice of how to break into healthcare and break into the field, that's what we're doing in the Healthcare Automation Lab. Link is in the description if you're interested. Thanks for watching. And until next time, query responsibly, and I'll see you in the next video.